Today to the skid-based processing equipment. I'm John Milbury, and today I'm joined with Jen Oster. We're both from Solidworks Corporation. And before we begin, I'd like to give you just a little bit of housekeeping hints on how to utilize GoWebinar. So real quick, you can see you probably have a control panel. There's an arrow there that will allow you to expand the control panel, as well as during the presentation today you can type in questions, and Jen Oster will be able to answer any questions that you've got live during the webinar. Also too, you can click on that arrow, that orange arrow, to collapse the control panel. So today you can take a look at the demonstration set that I'm going to be utilizing. Today we're just going to focus on two tiny pieces of SolidWorks capabilities. We're going to be focused on piping and weldments and how they pertain to skid-based processing systems. So if we take a look for today, we have a table of contents that we're going to utilize. We're going to go over first an overview, and then we're going to show you some real-time piping. We're going to create some piping drawings. We're going to create some weldments and then some weldment drawings. So real quick, as part of an overview, most of you who are familiar with SolidWorks understand that SolidWorks has three file types. One in the upper left corner is called parts. Over to the right you see assemblies, which is nothing more than a collection of different parts. And in the lower left corner you can see that we have drawings. And drawings can be of parts or assemblies. The key thing to remember though is that SolidWorks is associative across all this engineering data. So what happens when we make a change to one of these different types? Let's come in and let's make a change to our part. And when we do that and we rebuild, what you're going to see is that all of the assemblies and the drawings that reference this part automatically get updated. This guarantees that you as engineers or you as consumers of engineering data always have the most current and up-to-date version of your parts. So let's go ahead and let's jump directly into piping, and let's take a look at what it takes to actually create a pipe route. So you can see here's our demonstration set, and what's interesting is we're going to be focused today kind of on this Gould pump. And we're going to look at the discharge side of this pump to create a route. So I'm just going to come in here and we're going to go to a route pipe. And one of the things that we can do is come over to our design library. SolidWorks comes with a number of different piping components. One of these are flanges. We're just going to support drag and drop, and I'm just going to drag this over to the Gould pump. Notice that it auto sizes automatically. And for those of you that are familiar with SolidWorks, you'll notice that the familiar configurations, the ability for one part to take on different sizes, is definitely a key part of our piping library. Here, for example, it understands that we've got a 4-inch pipe and it wants me to choose a certain class of flange. We're going to choose a 150 and select OK. From there, SolidWorks actually comes in and it starts to create a subassembly for my route. It's going to allow me to do different things such as specify weld gaps, choose how to handle elbows, whether I want them to be bent or not, even coverings that could go on here. All this looks good to me, so we're just going to go ahead and hit OK, and SolidWorks is going to come up and actually give us kind of a stub route. Now, to get an understanding of how easy it is to route, if you can draw lines in SolidWorks, you can route pipes. Let's come over here and let's just draw a line. And you can see that I'm just going to draw it over here to the right, and you can see that SolidWorks automatically creates a pipe and the appropriate elbow that I specified earlier. Let's come in and let's continue with this, and we're just going to pull over in this direction, and I'm just going to put a leg or a pipe over in this direction as well. Pretty simple to do. All I've really done is created lines, and I've had the elbows automatically form for me. Let's go ahead and let's add another component. What we'll do is we're going to drag a weld neck flange over to this this other flange, and just release And you can see once again that SolidWorks knows the actual size that I need for that flange. And it's giving me a stub length. What I'm going to do is I'm just going to connect these two together by dragging and dropping. A really powerful technique. And if I want to be able to manipulate this, I can use dimensions, or I can just drag this out. Now a great question that comes out is wonder if we want to remove this pipe and go straight from this flange to an elbow. We just do a right mouse button click and go into remove pipe. Very easy and quick to do. Now we want to continue on with this route, but we've kind of throw a curveball in here. What we're going to do is we're going to mix different size pipe nominal diameters together in the same route. This is actually a 3-inch long weld neck flange, and what we're going to do is we're just going to go ahead and grab this and we're going to drag another flange over to it. Notice it auto sizes and it understands that this was a 3-inch. Let's go ahead and accept that. We're going to get that pipe stub again. Now what we want to do is we want to actually route to an area down here in this vertical 4-inch pipe. So what I'm going to do is I'm going to use a special command called split entities, and we're just going to split that. Now I'll be able to route to this point. What we'll do now is we're going to do some really cool advanced functionality. Let's come in and let's do an auto route. And I'm going to specify this point to auto route to. One of the interesting things is SolidWorks right away knows, hey, you're trying to route a 3-inch to a 4-inch pipe. I just want to let you know, and click OK to continue. And that is awesome. And as you can tell with the auto routing, SolidWorks is pretty much going to find its way any way that it can with an orthogonal route path. This path is not going to be acceptable, so let's select the next alternative path, and we can see that we get one that looks pretty good. We're going to go ahead and accept that, but really there's some problems with this as well, some clearance issues. Let's take a look at this. We actually want to, our design intends to keep this a certain number of inches away from the back of the cabinet. We can do that easily by specifying the dimension from the pipe over to the actual face of the cabinet. For this particular distance, I'm going to put in 3 inches. And you can see if we come into the top view that this 3 inches has been maintained. So let's just slide it right over here and we can see that. One of the things I want to point out also is that it's from the outside diameter of the pipe, not from the center line. And this is great. So let's continue on, and you can see that SolidWorks also has flagged me for an error right here. You know, we've got a missing elbow here, or a missing connection between this 4 and 3 inch pipe. Let's come over to our design library. Let's go into T's, because that's how we want to deal with that. And we know that it's going to be a reducing outlet T. We're going to drag and drop it. We're going to let SolidWorks decide the right size. When I release, it knows that it's got a 4-inch by a 3-inch port required to make this connection. I'm going to go ahead and select OK, and you can see it's been fixed, and it's in great shape right there. So that is exactly what we want to do. And now we want to do something a little bit more complex. What about inline equipment? Let's take a look at how we're going to handle that. So what we'll do is we'll come over here. We're going to just scroll on down a little bit, and we're going to take a look at possibly a ball valve with maybe with 4 inches. Let's take a look at this, flanges. And all I'm going to do is just drag this, and you can see that it's going to snap to fit on any of my pipe routes. You know, just fantastic capability. I'm just going to kind of place it over in this area and release. And now SolidWorks is going to allow me to clock this at any angle. This angle is perfect for what I need. And what may not be very obvious at this moment is that SolidWorks has also trimmed back these pipes accordingly. So we've gotten a pretty good pipe run done in seconds. We know that it's visually exactly what we want. Let's go ahead and let's jump out of the route. And we can see now that these temporary graphics that we've got are being replaced now with actual real parts. And you can see now also that SolidWorks, if you look on the left side of the feature manager tree, you can see that it's put it on its own subassembly. Let's go ahead and let's open up this subassembly. And let's take a look at what we can do with this. So let's come in and I'm going to turn this to white background so you can see this a little bit easier. And you can see that here's our subassembly. This is great because this allows me to be able to create drawings very easily from these particular routes. What's also very interesting is I can continue to work on these routes just within this uncluttered environment of the subassembly. Let's come over here for a moment and let's do a few things. Let's come in and let's do maybe a threadlet, and what we're going to do is we're going to add a pressure gauge. So we're going to begin just by dragging and dropping a threadlet onto here. And again, it's going to give me, it knows it's a 3-inch pipe. We're going to go ahead and choose the appropriate weldolet. I'm going to go ahead and just kind of lock that in there. Now I want to be able to define my intent. Since this can be rotated, we're just going to come into the top plane. We're just going to go to the top of the threadlet, and all we're going to do is just add a parallel mate. Pretty simple and easy to do. Now what about the rest of the equipment that's going to go on here? How about the gauge itself? So let's come on down and let's go ahead and grab that pressure gauge. Again, I'm just going to drag and drop and release. And you can see that that pressure gauge just come in there pretty easily and snapped right in place. Let's take a look at that from a front view. And there we have a completed route that took just a few minutes to do. So let's spend a moment and come back about what did we just see and what are some of the benefits. Well, with piping, one of the things you had to see was how easy to use this actually is. One of the things too is that 3D pipe routes are incredibly accurate. All the cut lengths for the pipes are known and captured, and you're going to see this information fall out in the drawing. And of course, 3D visualization removes a lot of the guesswork, just like when I corrected some of the interference that you saw earlier. So next what we want to do is we want to focus just a moment on piping drawings and what that looks like and how do we create them. So one of the very first things we can do is just come up to Solidworks and just say make a drawing from an existing part or assembly. In this case I'm just going to choose a template. In this case it's going to be a C-sized piping template, and we're going to get a lot of pre-created views, and this is fantastic. What we're going to do is we're just going to turn on these center lines, and I'm just going to start to add a little information. So maybe we're just going to take a dimension and we're just going to come in here and just kind of grab this angle. This looks great. Let's come over here and let's maybe add maybe a, I don't know, a horizontal dimension if we want to, ordinate, or we could do a vertical. Let's go ahead and let's do a horizontal, and let's take a look at what we could get there. So I'm just going to pull this up. I'm going to go back over here to my pressure gauge. We're going to get its location as well. And voila, we have a few dimensions. Pretty simple and easy to do. What about actual piping itself, the bill of material? Let's go ahead and let's insert a table. Pretty simple to do. We're just going to go to a bill of materials. We've got a couple of different options there. We're just going to take the default. And you can see, I told you earlier that our piping was incredibly accurate. Well, there you can see for all the different pipes, we've not only got the size, the item number, and the quantity, but also the unique length for each one of these pipes. So now that we've got a bill of material, let's go ahead and let's get a few balloons. But before I do the balloons, I want to show you something that's really unique with Solidworks, and that's the ability to dimension right in an isometric view and have these dimensions be totally accurate. This is really, really nice because I can create, for skid base, I can create isogen type of drawings. Let's come up for just a moment. We might want to be able to add maybe a north arrow to this. We're just going to drag this out. I'm just going to kind of place it right here, and pretty simple and easy to do. Let's come in now and let's add those balloons. So what we're going to do is just come over here to the auto balloon. We're going to get a lot of different options, but you know, this looks pretty good. I'm just going to go ahead and accept that. And one of the things that I want to do is for this area right here, for that gauge that we added, I'm just going to delete these balloons, because what we're going to do is we're going to do a detail view for that. So let's just come in and let's do that real quickly with SolidWorks. We just come over to the area that we want the detail view for, and we just drag a circle around it. We're just going to run right over here. We're going to place it. And one of the things we might want to do is just add that center line to it. And now we're going to add some balloons, but we're going to do a little bit different version of that. Let's do some stacked balloons. This is a great time to do that. And we're just going to pull this up and we're going to select also then not only the gauge but the actual threadlet as well. And you can see items 17 and 16 are reflected right here in the bill of materials. 3x1 threadlet and pressure gauge by Omega Systems. So this is great and pretty quick. Let's just do a few more things. We're going to add just a couple of more ordinate dimensions, and for this we're going to do, let's do some verticals right here. And I'm just going to come over and we're going to just kind of document some of these locations, and it's going to give me a chance to show you something that's pretty cool. And that is the ability to, you can see that all of our ordinate dimensions move together as a group, but I may want one such as this one to be able to break that group alignment and just pull him over individually. And with SolidWorks that's very, very easy to do. So there we have our completed drawing. It's ready to be able to go to manufacturing. We could even throw more dimensions on it, more detailed information. But what's really important about this is to remember that this information is going to update automatically if there's a change anywhere to our models. We talked about that earlier. So let's come back for just a moment, and we want to go back to our actual top-level assembly and take a look at it for just a moment. And if I come in here and I take a look at it, I notice that this gauge is just a little bit close to this cabinet. I may want to make a change to this and move it out. So what we're going to do is just come on back, and let's just come in and let's just make a change. So I'm just going to come in and drag this over, place it about right here, and then let's just go back to our drawing real quick. And you can see with SolidWorks that the location for the gauge, the detail view, all of this information is updated automatically and stayed back actually in sync with everything. So this is one of the incredible values of SolidWorks, to be able to make these changes and have all this information and pretty much flow right through. So with piping drawings, let's take a quick moment to review. What have we seen today? We've seen that, well, drawing creation is pretty highly automated. We know that the drawing views are 100% accurate because they're coming directly from the model. And we know that the drawing remains up to date with model changes, ensuring that all of your deliverables are up to date with each other. So we've completed the overview, we've completed piping, and we've completed piping drawings. Let's take a moment and let's move on to weldments. And so what we want to do is I'm going to come in here and we're just going to focus on an area for just our weldment. And let's go ahead, we probably don't need to see this pipe at the moment, so let's go ahead and let's hide that as well. And you'll notice that this pump, this Gould's pump, really doesn't have any sort of weldment stand. And so what we're going to do today is we're going to create that stand. And the way that we're going to begin to do that is we're going to insert a new part. And we're going to do it right here at the assembly level. Pretty interesting. And I'm going to go ahead and just begin to sketch right on this plane. Now what's interesting is we're in a sketch mode with this new part. What I want to do is I want to borrow some of this existing geometry. So all I'm going to do is I'm just going to select this bottom edge, and we're going to convert that entity. Now what's really kind of cool about that is I could use that entity and it remains associative. So we're going to go into our weldments now, our weldments tab, and what we're going to do is we're going to add a structural member. Lots of different members that we can add for this, but I'm going to go in and we're going to start out with using some ANSI inch plates. And for this I'm going to use a 3/4 inch plate. I can choose a size, but in a moment you can see I can also override those sizes. And we're just going to throw in a plate here. It's great. Maybe I want the plate to be just a little bit bigger. So let's come in here and let's just make a change to this real quick, and let's pull this out to 14 inches. And that's pretty much, that's a pretty good starting point. So let's come up right now. We're going to go ahead and sketch on this front. And what we're going to do is we're going to actually create the legs. I'm just going to start out with a line. We're going to come over here and we're just going to kind of drag this out. Now I'm also going to kind of, my design intent, as I go down, I'm going to capture this by selecting it and making sure that it stays on this floor. So when I move it, it's always going to maintain that contact point with the floor. Next, what we're going to do is we're going to come in and let's come in and do a midpoint line. So a lot of people have never seen this this command before, but we're just going to add a midpoint line. This is a great example on when to use it. Let's add a few dimensions to refine our design intent. Maybe we'll make this 6 inches long, and maybe come over here and dimension this this length right here. We're going to put that at about 4 inches. And right now there is some symmetry. I've done one side of this, and we're going to capture symmetry by utilizing a center line. And all I'm going to do is just drag the center line up. I'm going to go ahead and box select this information, and we're just going to mirror those entities over. Pretty quick and easy to do. Let's come over and let's jump on out of the sketch, and what we're going to do next is we're going to add some weldment members. So let's come up and we're going to go back into ANSI inch plates. Let's go to a 1/2 inch thick. Size, we're going to go, we're going to make these about 3 inches wide, and we're just going to select in a couple of areas right here. Really simple and pretty easy to do. Let's go ahead and let's select that, and we're going to make a change now. We're going to go into ANSI inch configured, and from here we're going to go into a rectangular tube, or no, let's go to a square tube. Probably be a lot better. We're going to go 2.5, 2.5 by a 1/4 inch wall, and we're just going to go ahead and select on one of those sketch entities. Solidworks is easily going to go ahead and place that. We're going to give you temporary graphics, and we can see again visualization is key with Solidworks. We can see that we've got some interference. Well, with Solidworks we can just say locate that profile. We get a great visual cue as to what that is, and we've really changed it now to where it doesn't interfere. It's kind of sitting on the bottom of this plate that the Gould pump is resting on. This is great, but let's continue on. So I'm going to go ahead and select right here, and I'm going to select this other vertical leg, and you can see that we're getting some what we call corner treatments, how they're actually being spliced together. We can change that, and we go to different butt weld situations. And what's nice too is on the butt weld we can also do advanced coping. So if I select on that, you can see that the coping is actually changed one of a contoured cope rather than just a flat end cut. And we're going to go back to our miter, and also I'd like to show you that we can individually override these at any given time for any particular joint itself. So let's just turn this on back, and we're good with this. Everything looks great. Let's just go ahead and select this and let's hit OK. Now, one of the things I need to introduce you to is our trim command for weldments. One of the things that you may not have noticed is that these legs pierce down into the feet. I'm just going to go ahead and trim both of these, and all I'm going to do is just select a flat plane to trim to, and just like that Solidworks is able to do that. Now we've got more symmetry in our design, and what we're going to do is let's come over here to our front plane, and what we're going to do is just come in here and we're going to mirror some bodies. So with that front plane, let's come in and let's mirror these bodies over, and again capturing that design intent for symmetry, and you can see we've done a great job at that. Now what we're going to do next is we notice that there's some mounting holes on this pump, and SolidWorks gives us some really unique capabilities. If I select on this Gould pump, one of the things we get is the ability to take our library parts like this and embed the fastening features and the manufacturing features together. So let's just select on this, and one of the very first things it wants to know is what is the plate that you're going to put in there? What are we actually going to drill into? Here's the different options you got for the hex bolts, the lock washers, etc. And you can see that SolidWorks is going to do a great job of just putting that right in there. Let's take a quick look. We'll just change the transparency, and you can see we've done a great job putting all that in for you automatically. So at this point, let's jump on out for just a moment, and we're just going to open up this part in its own window, similar to what we did a moment ago with our pipe. And you can see we've got a part. Let's go ahead and let's add a material. We're just going to turn this into plain carbon steel. And I want to be able to get some more stiffening members in here to give this a little bit more rigidity. So what we're going to do is we're just going to go and we're just going to sketch a line. And I'm just going to kind of come from this area right over here and just kind of pull this out. And we're just going to kind of, I'm just going to kind of connect it over here by dragging and dropping it until I get a little bit of feedback. That looks great. Maybe I could use a few dimensions to refine that. So let's just come over here and just select on that face. And just come over here and maybe give that a 2-inch gap. And we can probably do the same thing here as well. Let's put this out at about 2 inches. And that looks great as well. And from here, I think what I want to do is I want to use an L angle. So let's come back to our members, and what we'll do is we'll put in an L angle. So we're going to choose the L angle, and we're just going to choose a pretty small one. Let's go to 1 by 1 by 125, and let's just select on this. And you can see that we need to orient this. It's improperly oriented, so SolidWorks gives us a great way to do that. I'm just going to say rotate it 90 degrees, and again, we're going to get this this nice L angle in here. Now, one of the things that, again, I need to show you is the ability to trim this geometry. So let's come over here for a moment and let me just show you. We're going to go ahead and trim this body, but we're going to do something more. We're going to trim this away, but we also need to extend this. And you can see that SolidWorks allows us to extend, and all I'm going to do is select a couple of faces. And we're just going to do that. And again, very easily that's been trimmed up and extended. Great job on that. Now, I want to be able to copy this and mirror it to the other side, but I don't want to actually mirror it. I want to be able to create the most rigidity that I can, and for that, what I really need to do is rotate it into place. Of course, I could just create another one from scratch, but that's not really what I want to do. So I'm just going to go to the front and the right plane. We're going to create an axis to rotate around that runs directly through the center of our assembly. Now, what's nice about this is we're just going to come in here and we're just going to say, give me a circular pattern. I'm going to say revolve it around the axis. Give me bodies, and I'm going to choose this particular body. Again, SolidWorks is going to give us a great preview to that, and I'm just going to select OK. And you can see that that's come in there, and we've done a great job with that. So what you have to do now is put your attention over here to the tree itself, and you can see we've got items here. What I'm going to do is automatically update these cut list items, and you can see that items that are similar to each other are grouped together. And this is great functionality. Let's come in and let's review some of the information that we might want to be able to have on the drawing, or we might want to add additional information to appear on a cut list table. Let's just come over to our cut list table and let's specify one, cut list table with an angle. And now we get a preview without ever creating the drawing exactly what our cut list is going to look like. And you can see the item number, quantity, description, and length are all part of that cut list item. Now, as nice as that is, there's something else that we really need to pay attention to in weldments, and that's the ability or the requirement to do weld beads. So let's just take a quick look at how we might do that. I'm just going to select weld bead up here, and I've got a pretty cool capability, and it's called the Smart Weld Selection Tool. And all I'm going to do is just come down here and I'm just going to kind of paint an area, and I want this to be all around, and I want it to be tangent propagation. Let's come over here and let's do that on this as well, and let's do it right here, and let's do that right here as well. You know, great capability. Now, we've kind of got that figured out. Let's come in and let's come up to this area right here, and let's specify a weld bead across this. But I'm going to do it a little bit differently this time. I'm going to go ahead and select, and I'm just going to select this face, and we're going to turn off the tangential propagation, and we're going to come down and select intermittent weld. So now I can go ahead and I have the ability to specify a gap in weld length or pitch in weld length. maybe for the weld length I just want 1 inch, and we're going to give it a gap. And you can see that SolidWorks is going to do a great job at that. We're just going to hit OK. And one of the things that's important to understand is that we also created these weld symbols for you. And we can change and update these weld symbols. And you can see we're going to be able to utilize these on the drawing itself. If you want to get a visual idea of what the weld beads look like, we can turn that on. And that's a great thing because we can see that this 1.25 is probably a little bit big. So let's come in here and let me show you how we're going to edit that. So let's just edit this feature. Let's come on down and let's create a 0.25. And we're going to hit OK. And we're going to be right back to the actual size that we need. With SolidWorks, it's really just that easy to make changes. So let's go ahead and let's take a quick review of kind of what we've done up to this point. So with weldments, you know, again, the weldment creation is highly automated, very similar to the piping that you saw earlier. We know that the weldments are 100% accurate. We're making these cuts and these trims, and you've already seen a little preview of the actual cut list itself. Also, too, accurate manufacturing cut lists reduces errors down on the shop floor and when creating our prototypes. So we could see that probably next what we want to do is take a quick look at weldment drawings. You know, how do we create those? How do they work? And so that's the fun begin. So with the weldment drawing, what we're going to do is we're going to create very, very similar to what you saw earlier. We are just going to make a drawing and we're going to specify a template. And SolidWorks is going to do a great job of putting these views right out here for us. You know, great capability. Now, one of the things we might want to do is let's get to that cut list right away. So I'm just going to come in here and we're going to say, give me a weldment cut list. I'm going to hit OK. And we're just going to place it up here. And what's kind of nice about this is that we have both angles as well as the total length, the description, the quantity, and the item number. So now you know the actual angles on each end of these particular components, such as a tube that's square or an L angle. Great capability. So let's come in for a moment and we've got that cut list. Let's go ahead and let's add some balloons to this. Once again, we're just going to go into an auto balloon mode. For this, I like to ignore multiple instances, and maybe if we attach these to faces, that would be kind of cool as well. We'll come in and maybe do a different layout. Right, kind of just do this a little bit differently this time. Just one of the options. And one of the things I'd probably like to show you at this time is that SolidWorks balloons are highly intelligent. So if I were to take and move this balloon over to a different item number, you see it's going to update and change automatically. That's the power of SolidWorks, and everything stays up to date. Now, let's come over for just a moment and let's come in and let's put in a few dimensions. And probably what we want to do is I want to go to hidden lines removed completely to do this. It's just going to make it a little bit easier. And what we're going to do is we're going to go to a smart dimension. And let's go ahead and let's do this. I'm going to show you two different ways because there's some pretty cool things here. I'm going to show you the traditional way that you've seen me do, like just adding a dimension. But what about utilizing Dim Experts? Dim Experts can allow me to select maybe a location to be able to rapidly put in dimensions that are linear as well as baseline for this particular example. And I'm just going to go ahead and start to put these in. And you can see that SolidWorks is going to do a great job just positioning these and allowing me to quickly get some of these dimensions. So again, SolidWorks does a great job with that. And you can see that I can add more dimensions. I can refine this any way that I want. And pretty quick and easy. We're just going to move that over. And again, nice capabilities to get that quickly done. Now, remember the, remember the weldments that we did, right? The weld beads? Let me show you what we're going to do with that. We want to reutilize all that information. So those are actually model items, and in the model, and what we're going to do is I'm going to come over here to annotations. I'm going to say entire model into this drawing view. And all I'm going to want are the weld symbols. And oh, by the way, I can add caterpillars also that are really going to give us kind of a 2D drawing version of what a weld looks like. And we're just going to hit OK. And we can see that Solidworks has done a great job with those little weld bead caterpillars. We've also got our weld symbols that we utilize. And you can bet if we make a change to any of that weld information back in the model, it's going to update automatically right here. But it's also bidirectionally associative, so if I make a change here, it's going to update in the model as well. You know, great capabilities, but you know, what about if we want some more information about weld beads? Let's come in here, for example, and let's insert yet another table, and this time we're going to use what we call a weld table. I'm just going to do a very simple one to include drawing annotations and combine the same weld type. We're going to hit OK. We're going to place this right down here. And it's going to give us some information about the total weld length of this, and we can add costing information and a lot of information to this that I pretty much just glossed over and did very, very quickly. I'm just going to kind of shrink this down a little bit, and there we've got a great little weld table. Now, a lot of people ask me, John, but what about individual items or weldment pieces that appear within the actual weldment assembly itself? I'd like to detail those individually. How do I do that? And that's a great question. So we're going to go to View Layout. And what we're going to do is we're going to create a special kind of view that's called a relative view. So what I want to be able to do is I just want to be able to select on a view. In my drawing, it's going to take me to the model. And here I can say Selected Body. And what I want to be able to do is select on that plate, right? We've got a machining operation on that plate, drilled and tapped holes. So we want to be able to get a good understanding of a drawing for that. So I'm just going to specify the front view, and we'll specify a right side view, and we'll just hit OK. And it's going to take us right back to the drawing. And you can see here I'm just going to kind of place that. And this is great. We're just going to go back and create some drawing or some dimensions. Let's do that real quick. We'll just place some dimensions right here. And you know what's really cool too is that it's going to follow the bill of materials. So if I come in, for example, and I say, give me a balloon, I'm just going to kind of place this balloon over here, and you can see that it knows that it's item 4. You know, that is great. So I've got this individual component detailed out. I still need some information for where these holes are, and I could get that information really easily, but I want to show you yet another really cool table that we can do. So let's come up for a minute and let's do what we call a hole table. And for this, all I'm going to do is I'm just going to select down here and select an X and a Y location. I'm going to go ahead and select this face, and we're just going to go ahead and create that table. And you can see the table comes in automatically. It's pretty cool. Everything's labeled A1, A2, A3, A4. I can also change this tagging and a lot of different ways to change how this table looks. We just come over for the table. In fact, I can combine same sizes if we want. We can just do that. And let's resize this on down and get it just a little bit smaller. So there I think you've seen just some quick creation of a weldment drawing. Pretty simple and pretty quick. So let's come on back to weldment drawings and let's paraphrase what we've seen or summarize. Again, weldment drawing creation is highly automated. And the weldment views we know are 100% accurate because they're taken from the model itself. And accurate manufacturing cut lists, hole tables, and weld tables all reduce errors and scrap out on the manufacturing floor. So what I want to do is I want to talk to you just very briefly about the 3 different tiers of SolidWorks CAD packages. The very first tier is SolidWorks Standard, which does include weldments and a number of different capabilities, such as the ability to create any kind of part. It creates advanced surfacing, sheet metals, etc. Our next CAD package up is SolidWorks Professional, and that's going to include automated cost estimation, photorealistic rendering, file management tools, and a parts library. What's interesting is SolidWorks Premium, though, is required, because it's going to give you the ability to do the pipe routing that you've seen today. And that's not only fabricated pipe, but also electrical wire routing. It's going to give you reverse engineering, as well as ECAD, MCAD collaboration for printed circuit boards, and of course the ability to do linear static analysis for parts as well as assemblies. So in today's demonstration, if you wanted to be able to create the skid and do what I did today, Solidworks Premium would be the package that you would want to use. So what I want to do is just kind of show you a quote from Travis Brown, a Solidworks customer out at U.S. Water Engineering and Equipment. Great quote from Travis. And so I want to thank you for attending today. I know this has been a quick webinar. I hope I've been able to show you some things that you found interesting, and at this point I'd like to take any questions. And I think I see one of the questions here. It says, can you cut holes in a weldment member? Actually, you can, indeed. You can cut holes, and it's very simple to do in both pipes as well as the weldments. Isometric drawings from the pipelines, that's great. One of our solution partners is Alias Isogen, and our PCF files is already fine-tuned to go directly into Alias Isogen. You'd have to see the Alias Isogen dealer for that. We also have a solution partner called SMAP3D, who also includes Alias Isogen for doing that. See another good, there is going to be a recording available for this, by the way. Somebody said that was fast. Can I get a recording? Absolutely. How do we add non-standard components to the parts library? This is a great question. So what you can do is just build a part, and all you do is just put it in a folder that you've specified as a part library. And from there you can see that you can just drag and drop it from the design library just like you saw me do during the demonstration. In fact, there was a few components there that were custom created by me for this particular skid system. So how do you add different flanges in the design library, such as tricamp ferrules? First of all, you just model those and you put them in the library. Then what you do is you add a special piping capability called a control point, or what we would call a C point. What that does is that defines some information that our piping environment needs, and one of those would be the nominal pipe diameter, as well as where the pipe is going to start and end in relationship to that particular component. So here's another question. How would you accommodate sanitary fittings with clamps and gaskets? Very, very simple. The clamps and gaskets would be a drag and drop, very similar to what you saw me do with the threadlet, as well as with the ball valve with 4-inch flanges. Okay, somebody said I think the flanges were accurate. They are, and they follow standards. We want to validate dimensions of parts themselves. Not a problem. The library comes free with SolidWorks, and you're free to make any changes to it, especially dimensions or whatever with the flanges. Very simple to do. Can you explain smart features? Yeah, smart features are kind of cool. So what we actually do is we put this information into a small assembly. We put we drag in, for example, the Gould motor, and we place it on a piece of steel, and then we use in-context relationships to create the holes, the threaded holes, and then we go ahead and we add the fasteners, in this case some threaded hex bolt, lock washer as well as a flat washer, And then what we do is we tell this tiny assembly that it is a smart feature. And it then walks us through, what components do you want to use and what features do you want to use. And when we hit save, it's now a smart feature. And it's very cool. It takes seconds to do, very easy to do, and then you just drag and drop it. Great question, though. Can I share a PDF copy of my presentation? Absolutely, we can do that. If the flange isn't in the toolbox or in the library, what's involved in creating one that works with the routing features? It's very, very simple. I kind of went over that a moment ago. Also, where can we download the configurations smaller than 2-inch square tubing and rectangular tubing? That is great. In fact, you'll be able to get that right from within Solidworks. And Jen, if you would go ahead and yeah, there's a couple of different ways to do that. When you install SolidWorks, you can go into the property pane on the right, and you can actually hit an icon and it will take you there. Let me see if I can kind of show that. I'm not sure if I can at the moment, but pretty simple to do, and you can get that. If there's any problem, give me a shout at john.milbury@3ds.com, and I'll be happy to provide that to you. Here's a great question here. Can you change the default naming convention of the route assemblies instead of prefixing with pipe 1, etc.? Yes. Yes, you can. Where is the recording going to be available? We're going to send an email out for everybody that will contain a link, a hyperlink to the recording. What is the benefit or purpose of the Routings Manager? That's a great question. What it does is it allows us to be able to create different libraries and to be able to utilize and change between those libraries very quickly. A good example would be a tube routing for tubing made of copper versus one for Incaloy 925 for butt weld pipe versus maybe cold rolled steel that was duct or could be square ducting. So the Routing Manager takes care of a lot of the automation required to kind of build these libraries. And here's a great question. For custom weldment profiles, and I get this all the time, especially for complex aluminum extrusions, is single files better or single file table driven configs? I prefer single file table driven configs simply because I think it's just easier. Another great question here. Let me see here. Does pipe routing automatically create weld gaps, which would vary from stainless steel versus carbon steel? Yes. In fact, when I started the route, after dragging the first flange, one of the options was to specify what gap I wanted, what weld gap. And typically, for plain carbon steel like that, I would use about a 1/16 as a gap. Today I went ahead and used 0 just because it and to point out the fact that there was an option for gaps. So that's specified and very easy to do. You can override that on a gap by gap basis as well. So if you've got something that you specify 1/16, but there's an area in there that you actually want to specify, a unique area that you want to specify at 1/8, you can override it just for that. Is there a metric package available? Yes. Everything that you see for piping comes in both metric for both the weldment profiles as well as the piping parts. Can you change the weld type after the weld is done? Yes. If you saw me do the intermittent weld and I wanted to come back, I would just say Edit Feature and I would remove the intermittent and I could change that weld type very easily. And of course the weld symbol is going to update as well then. Can provided descriptions be changed to conform with company standards? Yes, they can. If yes, briefly, how please? You would simply open up the component and do a File Properties, and you would go in there and you would change the description name that's embedded inside the actual part component itself to whatever you wanted it to be. How can you use the design library with PDM? Oh, that's a good question. Is it possible to have the design library shared and controlled? It is possible. to do this, and it's probably a little bit out of the context of this discussion right now, here and now, but you can do that, and we have a lot of companies that are doing that. That's a great question, though. For a little bit more detailed answer on that, please check with your reseller, and they can explain to you how that is done. Can you walk us through a routing component wizard? Well, I can't right now, and I probably should have, but it's really pretty simple to do. I do it manually. It's just the adding of C points and connection points to make it pipe intelligent at that point. And again, that connection points can contain the nominal diameter for the pipe as well as where the pipe is going to start in relationship to that component. Can you automatically generate a bill of materials from Solidworks based on the parts used in the models? Yes, of course. And I think I saw that with all the different tables that I did today. When will Solidworks include socket weld fittings to the library? We actually do have socket weld fittings, or at least I have some. And if you want to, send me an email for that, john.milbury@3ds.com. I believe that what we're doing is we're providing threaded, but I also have socket weld. So give me a shout. I'll be happy to deliver those to you. Adding custom part numbers for BOM tables and or custom descriptions for weldment must be as simple as adding the custom properties of each weldment profile in the library. Is this correct? That is correct. Yes, sir. How difficult is it to associate piping and weldments to EPDM? It's as simple as simply dragging and dropping the actual parts, everything that you saw today, directly into the EPDM vault. Very simple to do. And Enterprise PDM is now called, in SOLIDWORKS 2016, we've renamed it to PDM Professional. It says I'm only on in 2015, but when we create plate using extruded bosses, it does not create dimensions that show up in a BOM without adding a bounding box. Is this not correct? And that's interesting. Yeah, basically what you've done is you're just creating, you're just using, there's a trick to actually do that for when you use plates and to make it show up the way mine did. And the way that you do that is you create it as a profile. So you saw me add a 3/4 inch plate and a 1/2 inch plate. What's interesting is there is a technique for that, and what we'll do is we actually create a library of different rectangular shapes just for plates. That's what we did, and once you do that, that information for the length and the width shows up automatically in your bill of material without having to use the bounding box. That's a great, if you need a greater explanation on that, please speak with your reseller and they can elaborate on that. Is there any electrical package available for tray and conduit routing? Yes, there is. In fact, the routed systems that you saw me use today for piping in premium also includes electrical package, and we do have conduit routing and electrical routing right there within SOLIDWORKS Premium. So once again, you get, with SOLIDWORKS Premium, you get not only butt welded tubes that you saw there, but any type of routed system, including electrical. So it's very, very flexible. Oh, email address again, too fast. Sorry about that. My name is John Berry, and it is spelled, my email address is john.milbury@3ds.com. John is pretty self-explanatory, but Milbury, let me explain that. It's M-I-L-B-E-R-Y. john.milbury@3ds.com. So we've got about 5 more minutes, and we're coming up on the hour. We've got about 5 more minutes, and it said somebody says it would be great if a future webinar got into specifics how to create custom routing parts. Sanitary fittings, etc. And absolutely, we can certainly include that. And what's really interesting is it's simple to do. And you know what? I think probably in the overview section of my next presentation, I'll spend a moment to be able to show you how to do that and how to create a connection point directly within a component that you build yourself. So that's a great request, and I will do that in the overview portion of my next presentation. Okay, let's see if what we've got here. Yeah, is there a good routing piping parts other than the standard Solidworks library? And you can go out there and you can find different libraries right here from within Solidworks itself. We've got a number of different libraries out there that you can go and connect to. And let's see, come right down here to the actual pane itself. Let's come to the home page here. And you can see here on the home page, you're going to be able to get lots of different areas. One of the things that you can do is you can come out and you can go out to a lot of different libraries that you'd be able to find right here through this these SolidWorks resources right here. Let's take a look. I was late. How can I get the recorded version? The recorded version will be sent to each of you. So if you've registered with your email address, we will send you an updated link for that. Here's a great question. Will you answer my question about the file vault? Yes, but I'm not quite sure what it was. The file vault, if I remember right, it said how can we utilize it with SolidWorks, and with PDM Professional, all you're going to do is just drag and drop and check that right in to the vault. It's very, very simple. So again, ask your reseller for any particulars on that. It's a little bit outside the discussion today. Here's a great example. I may have missed it, but was there a bend table example provided? We didn't do any sheet metal, so we did not actually utilize a bend table. When we get into piping though, or get into tubing, we're actually unbend stuff. We've got more capabilities there, but for butt weld pipe, we're simply using elbows to make that change in trajectory. Okay. I think that there's a lot of questions here. I'd like to get to all of them, but we are getting on to the top of the hour. So I want to thank everybody today for tuning in to this this webinar. It's been a real pleasure, and come back and we'll do this webinar again in a few months, and this time I'll go ahead and I'll sift through the questions, and we'll go ahead and we'll include some of the information that's been generated from your questions. So thank you very much. I'm John Milbury, and Jen Oster is with us today answering questions. Thank you for your time, and thank you for a great webinar.